In this lesson, you're going to continue to learn how to test your Node.js applications. Now, in the last lesson, we got jest configured in our application and we created a couple of test cases, even though they weren't testing anything real. In this lesson, we'll actually create test cases that verify a given function is working as expected. Now, for the moment, we're going to do that with new functions we'll create. We want to work with simpler functions at first as we explore these testing principles, then we'll move on to actually testing the stuff that already exists in the Task Manager project. Let's get started by creating a brand new file, and this file is going to live over in the source directory. So the source files that make up our application's code still live over here, while the test cases live in the tests directory. Now we're going to create a temporary file for this example called math.js. And let's go ahead and say that this contains some functions for common math-based operations we find ourselves performing throughout our application. And let's say one of those is something like calculating the tip on a given bill at a restaurant. So if my bill was $50 and I want to leave a 20% tip, what exactly would that be? Let's start by creating the function, and this would be the same regardless of whether or not we were testing the code. So right here, we'll create a constant. I'll call it something like calculate tip. This will indeed be a function, and I'll just set it up as an arrow function. Now we are going to need two arguments. We're going to want the total and the tip percent you're trying to leave. That's the information we need in order to run the calculation, and down below we can start to perform it. The first thing I'm going to do is calculate the tip that should be left. That would be the total. Let's say it's something like 10 for $10, multiplied by the tip percent as a decimal. So if I wanted to tip 30%, I would pass in 0.3. Right here, let's go ahead and add that into the mix. And now tip is going to store the tip amount. So if it was a $10 total and a 30% tip, we would have 3 stored as the tip variable value. Now down below, we can go ahead and continue on. I'm going to return the total plus the tip to let the user know exactly how much money they should leave. Now with this in place, we want to export this function like we would do for anything else we're creating. Right here, we'll use module.exports to export an object. And that's because we'll end up exporting multiple functions from this file throughout the video. Right here though, let's start with calculate tip as the only one we're exporting. Now, if we were going to use this in the Task Manager app, I would simply load it into one of the other files in the source folder and call it like we've done plenty of times before with other files and other functions. In this case, what we're going to do is write a test case that verifies this function is running the calculations correctly. So we're actually going to load that function in to our test suite file, and we'll be calling it in our test cases, making sure the value we get back is what we were expecting. So right here, let's go ahead and start by loading it in. Const math equals require. We're going to use ... to get out of the tests directory, then /source/math to grab the exports from the file we just created. Now we know we get back an object. That's what we're storing right here. We can destructure that object to grab the individual functions as variables. So I can call this one calculate tip to match up with the calculate tip export we put on the object down below. Now, this is a function we can actually call from inside of a test case to verify it's working as expected. Let's go ahead and create that test case by deleting the ones we had already and calling test for a third time. Right here, we'll be passing in the string, our test case name, followed by the function, the code to run, that makes sure calculate tip is returning the expected results given a set of input. Let's get started by picking a name for our test case should calculate total with tip, and down below the code to run. Now in this case, the goal is to test this function, which means that we want to call the function and make an assertion about the value we get back. We want to assert that the value we get back equals the correct value. So right here, we would do this using the following. Const, I could create a const like total. This will be the return value from calling calculate tip, and we'll pass in some numbers. We can pick whatever we'd like. Let's go ahead and say that the bill is $10 and we want to tip 30%. Now, if things go well, I would expect total to equal 13. That is the bill plus the tip. If it's not 13, then something has gone wrong and the calculate tip function is not working as expected. So right here, all we need to do is throw an error when total is not equal to 13. So if total is not equal to the number 13, that is a problem for us, and we're going to throw a new error, and we're going to provide a message as to why the test failed. Total tip should be 13, and then I could say something like got, followed by the value I actually got. I could go ahead and concatenate that on, or use the ES6 template string syntax to add that into the string. So right here, once again, if the total is 13, this code won't run and no error will be thrown, so the test will be considered a success. If the total is not 13, this code will run, letting them know that something has gone wrong. Now we can save math.test.js and rerun the test suite down below. I'll use npm test once again to get things rerunning. It should find my single test case, and right here, it is indeed passing. Should calculate total with tip took 3 milliseconds to run. I can see that everything is passing as expected. Now, what if calculate tip was indeed broken? What exactly would that look like? Well, over here, let's go ahead and say that we messed something up. Let's say that we accidentally add another value on, adding the total on twice as a mistake, and then I save the program not realizing that I've made a mistake. Down below, the good news is that our test case would catch this error and we would see a failure, letting us know that something needs to be addressed. Down below, we have our tests. We have just one and it's failing. And up above, we can see exactly what went wrong. Right here, should calculate total with tip. Total tip should be 13, got 23, and this would give me great information as to what's going wrong. I could then dive into the code, see exactly where things went wrong, remove the incorrect code, and bring things back to a nice working state. Now we could go ahead and rerun the test suite just to make sure our test case is passing once again, and if it is, we'll have confidence knowing that our code is working as expected and it's correctly calculating the tip. Now with this in place, I want to head back over to math.test.js and talk about a slightly different way we can get this done, the part of the test case that I have highlighted. So right here, we are manually setting up an if statement comparing values, and if we don't get what we wanted, we throw an error, saying something like total tip should be 13, but we got some other value. Now in this case, it only takes 3 lines of code, but there are other more complex assertions we'll be performing later on. For example, expecting that a given object contains a set of properties with specific values. So really quickly, we're going to end up starting to write a ton of code in our test cases to do things we're going to be doing over and over again. The good news is that Jest comes with an assertion library, a set of functions and methods we can use to assert things about values. For example, to assert that a given value equals another value, or to assert that an array has 4 items inside of it. So let's go ahead and see how we can use the expect library provided by Jest to replace the code right here. I'm actually going to comment that code out, though I will leave it in place, and we'll replace it with a single line right here on line 5. Now you can explore the documentation for what we're about to do over in the browser. I'm going to close down the Mocha tab, and from jestjs.io, we'll head over to the documentation. In the sidebar, we're going to scroll all the way to the bottom, and under API reference, we have expect. This is what we're trying to use. Now, before we dive into the docs, let's go ahead and see an example of what exactly it's going to allow us to do. Right here, Jest provides us with another function similar to test that we can access in our test cases. This is expect. We call it as a function, and we provide to it the value we're expecting something about. In this case, we are expecting something about total, so I'll pass that in right here. Now, the expect library ships with a dozen or so, actually more like 50, different assertions we can perform. One of the most common is to-be, which checks for equality. We pass in the value we're hoping for, which is 13. So if we read this out like an English sentence, it would be expect the value stored in the total variable to be the number 13. Now, if the total variable does equal 13, this code is not going to throw an error, and your test case will be considered a success, which is good. Now, if the total does not equal 13, this code will throw an error behind the scenes, meaning the test case will fail, and that's good too. It's going to alert you that something's not quite right, and you'll be able to adjust. So right here, let's go ahead and see what happens when I rerun the test suite down below. I run it. It runs through our one test case, and it still passes, which is excellent. Now let's go ahead and mess it up so it fails and see what we get. So right here, what I'm going to do is just accidentally add the tip on again. I will save math.js and rerun the test suite. This time around, it should indeed be failing. Right here, we do have one failing test case, and if I scroll up, what do we get? I get the following. Should calculate total with tip is a failure. Down below, I can see what I was expecting. I was expecting 13 and what I actually got, which was 16. So expect provides this nice little output just based off of the function calls we put in place. We don't have to do anything ourselves to manually generate useful messages, which is a good thing. We can keep our test cases nice and simple while still getting useful output. Now let's go ahead and remove the mistake that we had just created. I'm going to save math.js and we'll head back over here. So we took 3 lines of code and turned it into 1, but the good news is that later on, when we would have had to write dozen lines of code for a given assertion, we'll still be able to replace that with a single call to expect. So it's a super useful part of the Jest test suite. Now, if we head over there, we can learn how to navigate the docs quickly so you can use other assertions as you create your projects. Down below, we have different ways we can work with expect. Right here, we can call it with a value, which is what we just did. And then down below, if we scroll to the methods that start with dot, we can see all of the different assertions that we have available to us, and there are quite a few. For example, I can check using to-be null if a given value is null. I can check if a number is greater than or less than some other number. I have all sorts of assertions for that. I can check the length of something. I can check if objects contain specific properties. So there are a lot of useful features available to us, some of which we'll explore throughout the section, but the most basic is to use to-be to check that a given value equals some other value. Now, with our test case in place, we could refactor calculate tip. We could change how the function is written without changing its behavior, and our test case will make sure we haven't broken anything. So let's say we want to write this in a way that's a bit cleaner. Instead of creating a variable and then returning the calculation, I'm actually going to take advantage of the arrow function shorthand syntax. So I'll be removing the curly braces for the arrow function and everything inside, and right here I'll implicitly return the following value. We're going to take the total, we're going to add to it the total times the tip %. Now, from a functional standpoint, this is exactly what we had before. All we've done is we've refactored the function itself. Now, without a test case, you can't be sure that you haven't broken anything, but with test cases in place, we're going to be able to rerun our test suite and confirm that the old version of the function and the new version of the function are functionally equivalent. So right here, we have that one test case verifying that this is so. So already we're getting a bit of flexibility, allowing us to alter how the function works behind the scenes, and then making sure based off of the test case results that we haven't broken anything. Now let's go ahead and change the function, adding one more feature. We'll create one more test case. Then it'll be up to you to test a couple of other functions. So right here, over in math.js, what I'm going to do is add on a default tip %. So if you don't provide the percentage you want to tip, we'll go ahead and default it to something like 0.2 for 20% or 0.3 for 30%. The choice is yours. I'll go ahead and pick a value of 0.25 as my default tip value. So once again, if you provide the tip, we'll still go ahead and use that, but if you don't, we'll fall back to the default. Now, our one test case is indeed still going to work. We could always rerun it to prove that. What we're going to do now, though, is add a second test case to make sure that when we don't provide a tip %, the default value is correctly used. So right here, that's going to mean another call to test. I'll add a second call to test right here. I'll pick a name for this one, should calculate total with default tip. Then I'll set up the function, the actual test case code, and I'm still going to create something called total or something similar, so I can call calculate tip and store the value I get back. Now for this particular test case, the whole purpose is to make sure the default value works. So I'm only going to provide the bill total. I'll provide 10. Now down below, we can use expect to expect something about the total variable. In this case, I'll be using to to expect that the total is equal to 12.5. So $12.50, a $10 total with a 25% tip. Now right here, we can go ahead and run our test suite for another time, and we should see two passing test cases right here. That is exactly what we have. We are able to calculate the tip with a custom tip amount or with the default tip amount. And now our two test cases are going to verify that both of those paths work for this function. So in this video, what did we do? We created a function and we actually wrote some test cases for it. We also explored how we can use the expect assertion library provided by Jest to allow us to assert that one value equals another without having to write a bunch of custom code on our own. Now, in the next lesson, it's going to be up to you as a challenge to write a couple of test cases for some other functions we'll be working with. Then we'll actually move on to testing more advanced things like our Express application. First up is the challenge though, so let's jump right in to the next lesson.